All right, folks, today we are venturing into an incredibly thrilling project.
That's exciting. You excited?
Yeah, I am excited.
That is delightful mix of cutting-edge tech and a pure awesomeness. Remember our last episode where we crafted a semantic search using Flowwise and Langchain? Well, we'll buckle up, everybody, because this time we're turbocharging it with NextJS. If you happen to miss the previous episode, do yourself a favor and check it out, because the underlying logistics are very similar, but here we're actually going to code. So NextJS just recently released AI SDK that is packed with mind-blowing features, making it achieving our goals way faster and so much cooler. Because if you do stuff really fast, you're cool. With built-in LLM adapters, incorporating LLM into your code is now as easy as a pie. Simply pull OpenAI stream and streaming text response from the AI module in your Next.js SDK, and you're ready to rock. So the NPM package is called AI. The SDK also comes with streaming first UI helpers, which we'll use to turn our Next.js chat into a lean, mean streaming machine. And here is the cherry on top. Boom! The most revolutionary part of this SDK is not the streaming. Is the stream helpers and callbacks. These bad boys help you log every single conversation in a separate database like a boss or like a government.
I'm deeply moved that my government is looking out for me.
Anyhow, why does this matter? When your website has a chat, sure, your customers might get better service, and we care about that. But without logging those conversations, you're missing out on a gold mine of insights. With stream helpers and callbacks, you can analyze all that juicy data,
very juicy stuff,
on the back end and find out what your users are really talking about, the problems they're facing, and how you can level up your business. So in this epic adventure, not only will we be incorporating the SDK and building the amazing new project, but we also join forces with Pinecone, OpenAI from our previous setup, and for our piece de resistance, we'll log every conversation into a Supabase database. All the code, resources you need will be in the GitHub, so you can follow along and create something fascinating too. You could clone it, fork it, everything is there, nothing held back.
I give you my word.
This project is a delightful roller coaster of complex concepts and fun learning. We have this thing, it's called create index and embeddings. So basically this button, once pressed, will check the folder in your repository, whatever, to see if there are any new documents in there. And if there are any new documents, it will chunk them and spit them out straight into the Pinecone database. All right, so say something. You say, hello.
Oh my goodness.
My job as a software developer because of generative AI, right? That's a good question. And let's see what they say.
Artificial intelligence
Could increase labor productivity, potentially contributing to productivity growth. I loaded a PDF of a McKinsey report from June, I think, from June 2023. So it's fresh, okay? All right, so this is basically what you get. But the fun part is not even this. So we've seen this before, right? But the fun part is here. So you have a prompt on one side, and you have completion on that side. And then as also, you see, I played a little bit with the prompts and how I make the prompts because initially was getting a little confused. What is the actual question and what am I saying? All right, so we have prompts. All right, so this is what I ask. And the prompt also will have information from database, okay? So this is basically, here go user question, and vector database, what basically Pinecone returning back. And here we have basically the answer. All right, so Pinecone with Supabase. So before we jump into the nitty gritty of this code, let's get excited about the explanation animation.
I love learning from you.
So everything starts with a chatbot. Okay, as you see, it says user, hello, am I going to lose my job as software developer because of generative AI? So these are words. It has to go to a vector database. In this vector database, you basically will be able to do semantic search. But vector database doesn't understand words. So what you need to do, you need to translate it into vectors. Okay, so we'll go to vector base, but we can't. And that's why we're creating this embedder function that will basically translate using ADA002 model into vectors. So words became vectors. In vector database, basically all you have is vectors. And on the same line, you have corresponding to them words. Okay, so those are called chunks. So when we chunk any information like the PDF, every chunk of information will have vectors next to it. Okay, so basically the whole database is vectors and correlating to them words. A next step, what is that? Well, they cannot go by themselves to the LLM model because the LLM model will be like,
I don't understand this.
so now we actually have to combine them. We have to combine information from the prompt, the one that we asking, right? And the information from the vector base, because our prompt is not complete unless our question has information from the vector base, basically the matching words, matching information from the vector base. So we have to combine our words, the words from our question, and the database words. Okay, and altogether it becomes a prompt. In a regular conversation, the prompt is your question. In the semantic search, you need the database input before you could call it a real prompt that you will send to the LLM. And let's remember all the steps because this is exactly how we will building this application. So now we basically sending this prompt to the LLM. And here, basically, you say like, this is a user information, this is a question, and we have to let LLM understand which part is the user and which part actually came from database. Otherwise, LLM get confused, and the answers are really confusing as well. So what you put in, that's what you get, okay? We'll respond back to the chatbot, and here you have your conversation. We've seen this many times. Nothing new, unless you're new to this whole generative AI thing. We know how this works. What was a personal curiosity of mine is basically how to make it efficiently to log on to all these conversations. As I said before, there's a trove of many useful cases where you could use this logging in order to basically get insights about your customers, about your employees, a lot of things you could find from there. So by itself, these chatbots, they're nice to have. With this, they could potentially become must to have, and they actually will be solving a real problem. So now we are very close to something that businesses will pay money for, probably a lot. So this is pretty amazing. All right, so we have response. So what we're gonna do, because with this stream helpers and callbacks that SDK, Vercel SDK providing, now we could easily and flawlessly document the interactions between the user and the LLM. Like literally every interaction can be documented, okay? And it requires not that much code, as we're gonna see on the screen. All right, so here you go, database interactions. So basically what the database will record, it will record the prompt, okay? So the question, and it will record the response of our database. All right, and also the time created. So you could actually do, it's by default. With Supabase, by default, you have the ID and created time. So, and only just with this super basic database, you could create really interesting dashboard with lots of valuable information like Google Analytics, but for LLM interaction, which is really cool. So this is how we're going to build this. Okay. All right. So let's think about all the modules we need to build. Right. First one, we need to create embeddings. So this is going to be one module. Second one will be update embeddings and update your database with the new documents. Third one is going to be, we would need modules for completions, right? To basically interact with LLM and also to basically save information to Supabase. What the coolest part about it is that SDK, AI SDK also already has that, so we don't have to build this in SDK, all right? So this is the little walkthrough. Are you excited? So we'll go really fast through the code. Again, everything will be in it. I'll try to explain as good as I can, but a lot was graciously taken from the Vercel AI SDK examples. So you could find nice blogs over there. I have everything in there. And also, some of the code was inspired by Nader. When you will deploy this, I'll have it on GitHub. When you deploy this, make sure you have your env local. It's going to be called env local example, all right? But that's .env local. This is all the keys you need to provide to your services that you're using. So we have OpenAI, all right? We have Supabase URL, and we have Pinecone, all right? So we will need all of these keys in order for our application to work. Our program works. All our modules we're creating, all those 3 modules, we call them utils. All right, so code. So first, I think from the logic perspective, let's go with the create Pinecone index, right? Let's think about this. So you basically, it's the export as async function. Your function takes 3 parameters as a client, okay? Client is basically the client, the Pinecone client that will be doing all this work. Index name and vector dimension, okay? Here, you will be, again, Nader, as his code, he actually wrote, he has a 40-minute video of going step by step and the logic behind each of the steps. Console log, you're basically checking if there is index name. You're basically checking the index names, whether there is an index name there. If there is no such thing, it basically creates a new index name. Okay. So basically it just does that, and that's it. Basically it did just that. And if it finds the same index name, it just tells, oh, it already exists. So overall, fairly simple code. And when it comes to exact syntax and how to build it, again, Nader explains it over 40 minutes. And he actually shows you everything there. Here we have update Pinecone. This is the next module you really need. So this way, basically, this is how we upload information. All right. So again, retrieving Pinecone index. In this Pinecone index, we basically say like, oh, it matches our index name. So, okay. One more thing. The index names are saved in the config TS. All right. So basically, this is where you're gonna write for your app. What is the name of your Pinecone index? All right. Just remember that. We'll look at it right after we go over this one really quick. So here, this is the most interesting part, is how you process your documents. You take your documents, you put them in text, then you basically chunk them. So the chunk size is 1,000. It's quite a big size, to be honest with you. If you'll see responses that the Pinecone sending to in the database, in the Supabase database, one will see it. Nader had I think the top K number of 10. It's basically 10 pieces of content. It was a lot. The answers were long, and it was kind of all over the place. So I kind of made some adjustments, but anyhow, chunk size is amazing. 1,000, it's really big. It's about 800 words. So it's a big chunk size. All right. Splitting things into chunks. After we chunk it, we basically wait for it to create a chunk. And then we will basically and then we are using the embedding arrays to, and then we are gonna do this. Then we basically sending the, and then we are embedding them. We'll take all those chunks. Oh, okay, this recording video limit. All right, and after that, we basically check the chunks. We send them the chunks out, okay? And here you go. So basically, this is a chunking process. Again, if you want to know exactly what, exactly the logic behind it, the whole process, just look at his video. Is much more straightforward than it looks. That's it. That's basically you updating. Here you're querying, and again, top K, it was 10. I changed it to 3. It was a little bit too much information. My LLM was confused talking about some random stuff that it didn't even relate much. So just have less of a number, okay? Next, basically you do querying. Again, this is just a function that we'll be calling. It's fairly standard function. Pretty much every one of these videos on semantic search, they have some version of this code. So again, this is not the magic, but I really liked how nicely they organized his code. So this is make it much easier. So these are modules that I said we need to create. Here they're created here. Next, once we created our modules, what we want to do, we're gonna create routes. Okay, so we have in our API folder, we have 2 routes. One is a chat route and one is setup route. So the setup route is to upload information to the database. Here, when you see this information over here, create index and embeddings, what we'll need is basically route document, okay? So create index embeddings. Once you press it, it will be calling the route, right? And the route will be checking the data, the document folder, and chunking it and sending it up to Pinecone, all right? So let's see really quick how this works, okay? All right, so we start with import next response, Pinecone client, basically do all the important modules that we need in order to have it working. And you see over here, we are pulling our create Pinecone index and update Pinecone from utils in order to perform our functions. Also, we pulling our index name from config file that I talked about before. Let's look at the config file. Yay. So basically here you say timeout. Timeout is how long you will give it before saying like, oh, I cannot wait no longer, and probably the production failed. It's 180 seconds, okay? It actually takes this long. So let's just stay with 100, maybe even 200 something. Every time you have to create a new index on Pinecone, for some reason it's very slow. After we import information about our index, we basically we call this async function post. We checked if we have any documents in our documents folder, which is right there, right here. You see, I have the economic potential of generative AI as my information folder. We check it. We check whether it's a text file, MD file, PDF file. Then we will load this stuff, vector dimensions 1536. So basically we're creating all the necessary parameters for our Langchain to work, right? Let's see. Yes, text loader. So we're using the text loader from Langchain. We are using directory loader from Langchain, and we have PDF loader. So basically all this coming from Langchain modules, okay? So you don't have to write them yourself, which is very nice. That's why the code is so small. All right, so here we basically initialize in the client for Pinecone. And after that, we say, let's create a Pinecone index. And you only do that if you don't have that index name. But since AI simp is already there, and in my config file, AI simp is there as well. What we do, we don't do nothing. So we just move on and we go next, await update Pinecone utility that we created before. All right. And then return next response JSON data cycle created, index and load it into the Pinecone. Here you go. That's how it works. This is that. When it comes to chat, again, made a few changes here. So think about the chat. Okay, so again, we'll be pulling configuration OpenAI from OpenAI Edge because the new SDK allows for the Edge functionality. This is all part of the SDK because it comes from NPM AI, right? We bring in the Supabase client. Why? Because we will be collecting information. We'll be basically saving all that information. Pinecone client is here. Query Pinecone. So here, since in the chat, we're not creating anything. We're just querying information. We don't need all of the utilities, okay? And it is a little bit confusing. All right, so on the right side is a chat. On the left side is a setup route. Okay, so it's kind of like 2-in-1. All right, we initializing our OpenAI client, and here is our function for safe prompt completion that takes prompt and completion information. So we need this information in order to write information to our Supabase. Export a sync function post. Here we have messages that are coming from the user. We'll look at these messages. We embed these messages. We embed the message that came. We query the Pinecone with this query Pinecone vector utility we had from before. We pass all the things in it, all the parameters in it, and here you go. And we create a new message. Basically, a new message is where we're combining. Remember that big plus on animation? This is where we do the combination of all of the. Here you go. This is where we do the combination of all of the information, right? The prompt and the question. Okay. So next one, update array with the new messages. All right. So that is done, and all that together is being sent to LLM. So LLM, now you have the whole of the history, right? Of the history, and here we're just using create chat completion. Here we provide the messages, okay, and convert the response into friendly text stream. So this part will convert response into a friendly text stream, and not only that, but also it will save information. So when the stream starts, you have the current prompt. And after that, you're basically getting the string, and you're basically showing the stream that is happening. And after that, when the stream is done, we will take the current prompt, all right, that we saved in the beginning, and completion prompt, that basically the end of it, into the Supabase. Right? So we took it here and we took it here. And that's why it's very powerful, because you basically could put different functions during the stream and analyze the stream. So that's pretty cool. All right. So overall, this is how it works. This is our config file. So most important files again, this is our inner lib. We have Supabase living in here. Okay. So I'd say this is the 4 most important files again. So we have env local, all your information, okay? Utils is your utilities, right, that we created. These utils are used by chat. This is for querying. This is for uploading and checking if there is an index. And the last one is, and the config is basically telling what the name of your index. So anybody who wants to create their own application, especially that uses analytics, is very similar to Mendable at this point, that could not only give you the experience talking to the AI and also do the semantic search, but also have analytics reported to your users. This is, or to the person who bought it for the company or for the store. This is really big. You could have basically daily analytics auto-generated from your chatbot, sent to your SMS, to your phone, and tell you exactly what your users are asking. I think that is a great product. I think there'll be a lot of products like this in the future, and there will be, I don't know, 10, 20, 30, $50 per month per license. So this is a great opportunity. If anybody wants to make money in AI SDK just made it really easy to create a valuable product. Okay. For more, follow the account, like the account. We have another video will be less code. This was code based, but it's free tier. Okay, so my Pinecone is free tier. There was a question, can we make this thing free tier? So my Supabase is free tier, my Pinecone is free tier, my Vercel is free tier. So this whole application could be running completely free. Let's create something cool. If you guys find something with some really cool code, or if you guys end up creating something really awesome, or you have any suggestions on how to improve my code, let me know. I'm really passionate about this, and I really want to learn more myself, okay? Anything I learn that is, I think, valuable, that's what I share. All right? Cheerio.